Okay, let's start then. Oh my, all my windows are messed up. Let me fix it really quickly. Okay, let's go to 5. So, oh, I guess so. Enemies. Let's start talking about enemies. Okay, so like the first thing we need to do um, with enemies is like similar to the player. We should create a chat. Oh, I just realized I wasn't sharing my screen. Sorry. Oh god. Oh, let me share my screen. Wow. Okay, that was a dumb mistake. Okay, now I'm sharing my screen. Now you can actually see my code. But yeah, so like something that wait, actually on the round branch, I just realized that I should be on. Um, I don't see number 6 here. Why don't I see number 6 here? Oh, because it's down here. So we should be on collectibles. So like Annie said, the last thing that happened is that's not the last thing that happened. That is ahead. The last thing that happened is throughout the command to navigate branches, it should be git checkout dash f. But like the last thing, so we didn't add these yet, the collectibles. But essentially how they work is like they fall from the sky, you can run into them and they will increment your score by 10. So the top of there's a score thing. And I mean, that's like the basis of collectibles. So we're going to move on to enemies, and enemies are like a mix between like players where like they have like the same animations and like same sprites as players, but they also are like kind of like collectibles. Like we're thinking of them as collectibles, right? Because they're like other bodies in the world that you can interact with and like collide with, that are just not like besides the player, right? So let's go back to our creditor and let me zoom in so it's like nice and visible. So let me just take a note of a couple things. So one thing to note is that like from here on out, it's it's very helpful if we have like some sort of debug information or like things that show us like the game is acting properly. So if we go to index.js, which is like in the first workshop, Michael mentioned how this is a configuration for our game. You'll see like there's a physics arcade debug thing. Let's set this to true. What this will do is for like all the dynamic bodies in the world, it will draw a green box around them, which are like a visualization of their hitbox. So like in video games, when people talk about hitboxes and hurtboxes, they are like also the collectibles have hitboxes. It's kind of hard to see because it's like purple on a close to purplish background. There's not that much contrast. But like if you look closely, there's like a purple box surrounding our player. This is like where it intersects with things. There's purple boxes around the gears, which are the collectibles that we haven't added, or that we were like skipping over how to add. And yeah, also like the velocities are visualized too. So like when I move to the right, it shows like the player has a velocity to the right. That's what that green thing is, to the left and up. So that's helpful. And another helpful debug information we can add is like, so you notice it'll draw this for things that are dynamic bodies, but it doesn't draw it for things that are like tile maps. So the tile maps also have collisions, like I'm colliding with the tile, but it's not there. So there is this debug thing that we added during platforms, but let me just go over the code now. So this debug tile map layer, what this essentially does is it draws yellow borders around the tile map so we can see it better. So if we uncomment this code, so like what we do here is like we do this dot debug dot tile map layer, and then it takes in a tile map layer, and we can do foreground. So if you want to know like how this works specifically, you can just like check out the collectibles and then read lines 41 through 49. We save that and we go back to here. you will notice that yeah, so it draws a yellow border around it now, so we can see like where it's intersecting. And that's also explains some things, right? So like, if we go down here and we like jump into this wall here, it's like kind of weird. Like it was kind of weird before where like the player was like kind of not actually hitting it, and we can see now because the hitbox is actually around there, is like that whole tile instead of just like the top part. But yeah, so that's just debugging down. So the next thing we should add are start working on the enemies. So I'm going to go into, I'm going to click this button in the top left of Visual Studio Code to open up the files. And I'm going to go into SRC. So click SRC, components, and then I'm going to make a new file by clicking this button up here. And it is going to be called enemy, enemy.js. And so enemy.js, similar to player, we have to import phaser first because that's the library we're using. We call export class or export default class, which just essentially says, or let me just write that code. Export default class extends phaser dot physics.arcade dot sprite. So what this says, just reviewing workshop 1, is we're making a new class called enemy. And its parent class is this arcade sprite, which is the same class that player inherits from. And what a sprite is essentially just like an object in your game that has like animations that's represented. It's like a smaller image that you put into a larger game. An export default essentially just says, when we import this file, this is like what you use, the thing that's like after the export default. So like if we go back to main scene.js, right, now we can import our enemy from /components /enemy. So we're just importing it now. We're not really doing anything with it. So to move on, let's make the constructor, because every class, similar to like Java, or if you've used Java before, or like Python, it's similar to underscore init, is there are constructors which basically tell JavaScript how to make this class. And it takes in some arguments. This function takes in some arguments. It takes in an X position, a Y position. I think it takes in other things too. But I don't think those are like that important. So we do super, and super is what this super keyword does is it calls the constructor of the sprite class. So it's like we're telling it like how to construct the sprite in the super class. Okay, it's not giving me auto completion. Some kind of. Oh, okay, yes, that's true. We also need scene. And what scene is like, for example, main scene is a scene. So I go back to main scene, you can see extends phaser.scene. And it's just like a scene in Phaser is just like an organization of your game. So like usually scenes are split up into like examples of scenes, like you would have different scenes for levels, like different levels. You would have different scenes for like UI. So like you can draw scenes on top of the scenes. So like if you want a heads up display that's like a health bar, you would draw that using a scene. Yeah, so it takes a scene X, Y. So scene X, Y, texture. So we're going to be using a texture called enemy, and the rest of them are frame. The last argument frame is optional, so we'll just not include it. I think we have to do, so let me look at player, see what we did there, so I'm not missing stuff. So yes, we also have to add these lines, scene.add existing this and scene.physics.add existing this. You will like, if you don't add these lines, it basically will not tell Phaser to add this class to like the overall world. So like it won't appear. So we just need to do that. And similar to player, we want to create animations. So let's copy this line and do this. Let's have a create animations function. And let me do something. So a cool feature of Visual Studio Code is that you can like show multiple files you're editing at the same time. So if I hit Command Shift P, you know what? We will just do it the other way by not doing that. Okay, I will do that. So I will take this player. Wait, am I sharing my screen again? This technical blunder after technical blunder. Let me share my screen. Okay. Okay. So let me just drag player here. So if I drag it from the top bar, I can like move it towards the right. Okay, why is it being weird? Move it towards the right and like it like VS Code highlights the right side of my window. So if I drop it there, okay, just kidding, because I know VS Code is okay. Let me just put it on the left. Wait, I can do this. It's just my thing is lagging a lot, so it's like not doing it properly. Okay, anytime. Okay, it finally loaded. Thank you. So now I can see like my player class right next to my enemy class. So I can see like what I need to add. So create animation. So I need to create the animations. Let's just for now put in idle animation. So anims.create key enemy idle and the frame names. So let me actually open it up. So if I hit Command P and then type in enemy.png. No. Okay, enemy sheet.png. This is the, it looks very similar to our player one. Okay, any day now. Okay, so this tile sheet right here is like the tile, the sprite sheet for our, I said tile sheet, I meant to say sprite sheet, but the sprite sheet for our enemy. And the idle animation, if we count from the left, it's like 1, 2, 3, 4, 5. We want the fifth one. Let's just say frames 5. What else do I need to add? Oh wait, sorry, that's not it. It is frames this dot anims dot generate frame names from enemy. And then we want its prefix to be enemy dash, its suffix to be .png, because the way these are loaded into the texture atlas, it's like it's enemy dash 01.png, enemy dash 02.png. So we have to also tell it to 0 pad too. So like put a 0 in front of it if it's not 2 digits. And then we say the frames we want are 5. And then we can set a frame rate. It actually won't really matter here because it's just a static image. So like it won't change anything. Let's just make it 20 to be consistent. We can make it like even 1 or 2. So we've created this idle animation. Let's play it at the top. So play enemy dash idle. So like when we create the class, we play enemy animation. Why is VS Code giving me an error? Okay, it's not. So let's go to main scene. And like we imported this player sheet and player atlas, we need to do the same thing for the enemy. So let's import enemy sheet from, okay, I misspelled that. Sprites enemy sheet.png atlas from assets sprites enemy atlas.json. Okay, where's my preload? Here it is. So let's load it in. So like we do this dot load dot atlas enemy, because we have to use the enemy key right here because we used it in this class. We load in enemy sheet, enemy atlas, any day now. What was the import? Let me paste it in the chat. So these were the imports. Okay, so we imported the atlas. Okay, cool. So now we can move on to the next step, which is like we've made the enemy class. We've told Phaser this is okay. This class is how you construct an enemy. Now we actually need to add it. And a way to do that is we can just like So similar to the collectibles are just like placed randomly on the screen, or they're not placed randomly on the screen, but like they're placed starting at X position 64, and then it's like next one's 134, 204. Like that's what this code does here, the X64, and then step X70 is like for each one put 70 between it. We couldn't do it that way, but like a better way to do is like, especially if we're designing levels, is like to have a method of like putting it into our graphical editor and then having a way for our code to read that. So we do that with something called objects and tiled. So if I go to tiled, and I mean, there's already an objects layer here, but I will delete it and remake it just to show how it works. So let me yoink, it's gone. So if I hit this button right here to make a new layer on tiled, and then I hit object layer, and then I type in objects, okay, objects. I can now make objects. So like up here, you can see like these tools that we used earlier are grayed out because we're on an object layer. And these are tools for making sprites. So here, if we select this rectangle one, this rectangle tool, we can start making objects. And what objects are just like, earlier we talked about metadata. So just metadata associated with your tile map. And you can do things like say, okay, spawn the player here or spawn the enemy here. So we're gonna make one called name, I'm gonna name it. So you name it by going to the property window on the left. We're gonna name it spawn underscore enemy. And let's place a couple more. Let's place from here and then here. So we place those enemies. Let's save. So now in the code, we have to somehow read that we have enemies in these locations in the map. So like at the center of this square and then spawn an enemy there. So let's start doing that. Okay. Uh-oh. Uh-oh. No, it's just. Okay, there, create tile map. So we want to add in another layer. Let's call it const objects equals map dot get object layer. So this is different than create layer. This is get object layer and has to be an object layer. Let's call it objects. And now we essentially want to extract the enemy positions. So this is going to be like a little bit more advanced JavaScript that I'm going to write here, but I'll explain it. And hopefully you can get it. It's okay if you don't understand it too. There's other ways to do this. Like you can just do this with a loop. But let me just go ahead. So I'm going to take objects. And like if we look at objects and like look at objects dot, thank you. No. Objects dot. Okay, objects is not an amazing name for this because it has a child called objects. But if we do objects.objects, we hover over it in VS Code, we can see that it's like a list of these tiled objects things, right? So I said list, sorry, array. In JavaScript, they're called arrays. Is array of this tiled object thing. So what we can do is we can, on arrays, there's a special function called map, which can essentially takes every single item of that array and it converts it to something else according to like a function we write. So if we do objects.objects.map, and then we say like object, so it takes in a function, right? So let's make a function called const, what should we call this function? 2 coordinates, right? And it's a function that takes in an object and it returns a new object. Let's just say it's the X position of that object and the Y position of that object, right? Let me return that. Also, wait, is there anything confusing here? Because I realized we did not talk about the syntax. Any questions? This is just another way to create functions in JavaScript, rather than using like the function keyword. Yeah, but yeah. So yeah, 2 coordinates. So we pass in 2 coordinates, and then there's another one called dot filter. So right now what we're doing is we're getting every single object and like just getting the X and Y position. But like, let's say we add other objects later. Let's like, actually, let me do that right now. Let's say like we want to spawn our player here. So let's add a spawn player object, right? But we only want to look at the enemies, right? So what we can do is dot filter, and then we filter, oh, wait, okay. So sorry, we have to run this dot filter first because after we run map, we lose some information. So we have to do dot filter, and we take in an object, and we have another function that is, that essentially, so what filter is it runs through every single item in your lit or your array, and it like calls the function that we add to filter. And if it's true, you keep it in the array. If it's false, you remove it from the array. So if we say object dot name, so every object is a name, that's what the thing we say. If it's equal to spawn enemy, let me return this. So if this is true, then I'll keep it in the array. So now we can just say this is like enemy positions. And we can return that from our function. So now create tile map returns an object that has a map of foreground and enemy positions. So, okay, yes. So now, after we create our tile map, okay, yes. After we create our tile map, if we do this dot tile map dot for each, or sorry, no. This dot tile map dot enemy positions dot for each, which is very similar to map. It essentially does the same thing as map, but it doesn't return anything. It goes through each one. Actually, you know, let me use a for loop. So for every enemy of this dot tile map dot enemy positions, just so you can like get exposed to like different ways of doing the same thing in JavaScript. So we have this for loop here that like basically says for every enemy of enemy positions, we want to essentially spawn the enemy in. And before we do that, we actually have to create something called a physics group. So yesterday, or I said yesterday, this is like 30 minutes ago. 30 minutes ago, or like last workshop, we talked about physics, right? And we talked about like there's the idea of dynamic bodies and there's the idea of dynamic body groups. So we want to make a group because all the enemies have essentially the same behavior, right? Well, we haven't talked about the enemy behavior, but like essentially what they do is they walk left until they hit like a invisible wall and then they turn around and they just do that over and over again. And that's how our very, very rudimentary enemy AI works. So like, because they all have the same information and like work the same, we want to make a physics group for it. So let's say this dot, this dot enemies equals this dot physics dot add dot group. And we add a group. So let's say you add a physics group and we say it's class type is enemy. So we're finally using, this is like referring to the enemy class we made. What else do we need here? Like we need a key. So this is enemy. And what else do we need? Let's just do this for now and we'll figure it out. So then we can do this dot enemies dot create. Yes, create. So we're adding new enemies to this enemies group. And we want to use enemy.x, enemy.y. So now, hopefully, enemies show up once we reload our game. Okay, they showed up, but there's a very noticeable problem. The enemies are gigantic. So, like we did with the player class, we scaled them down because like the actual images are like 1,000 by 1,000, which is like really big. So we have to scale it down. And the way we did that is by using this like aspect ratio code. So like, I think Michael touched on it, but it wasn't like super in depth. But what this does is it essentially So when display width of a sprite is like the width and like the height is the height. So what it essentially takes is like, we just want to scale it down, but we don't want to like stretch it. So we have to keep it at like the same aspect ratio, like the same ratio between like the width and the height. So we have this aspect ratio. And then what we want to do is we want to resize it just like a different, like we want it to be like a different height. So we make a height constant here called 64. And then we do this dot set. Okay, wow, I did not type. This dot set display size to be the aspect ratio, because the ratio is like width over height. So if we multiply width over height by height, we get the new width, right? And then we want it to, so that's what we want the width to be, and we want it to be the new height. And this should like make the enemies much smaller and not ginormous. See, okay, so it spawns in the enemies, but this one is still ginormous. So let's figure out that bug. I think also let me move this down here. Let's figure out what's going on with that. That is weird that that's happening. Huh. Now, let me just try reloading it again, and maybe the bug will fix itself. Sometimes that happens with, especially game programming, is like something weird happens and then, okay, it's still ginormous. So I don't know exactly what the bug is, but I'm going to look at our next step and figure out what is going on if I missed anything. So right now we're on collectibles. And let's compare this branch. You want to compare this branch to, our next branch is enemies. Let's compare it to that. And there is an enemies thing. Our next branch. So let's see what they do. Let's see what we did. That seems fine. So let's look at main scene. Okay, it seems like we used extra arguments here. So let's just try that. So let's put enemy as like the key. And what else does create want? It also wants a frame. Let's just say frame 0, the first frame. Visible true, active true. And let's see if that changes anything. Okay, still ginormous. Huh. One of them is small, which is the weird part. Just spawn an enemy here, spawn an enemy, spawn an enemy. That's also, okay, and okay, let's just move on and like, hopefully the bug will resolve itself. This is always the error with live coding, is that random bugs that you've never seen before pop up. Maybe if I remove key actually, because I don't have that. But let me add runs child update, I think is the property it's called. Child, run child update, yes. And what this will do is like in our enemy, when we create a update function, it will essentially call this update function. So we can like update the behavior of the enemy. So we call super.update because like we want to call the sprites update first. And right now, let's not put anything in enemy. So let's figure out what is going on there. Okay, the bug fixed itself. I don't know what I did, but yeah, that's how it just happens sometimes with game programming. It's like things just disappear. But yeah, but you notice that our enemy, like what happened is the enemies spawned and they just like fell through the floor and they fell through the world pretty much. And the reason that's happening is because they don't have any colliders on. So first let's similar to player, let's like make this dot create properties. And in create properties, you want to run this dot collides with world bounds to true. So at least when they hit the edge of the world, they don't fall through it. So let's at least do that. So he still falls to the platform. Actually, wait, did he fall through the world? I can't see. He did. Okay, interesting. Wow, that's interesting. Okay, I don't know why that's happening. Another bug, but let's just move. Let's just power through it. So the next part is let's essentially add colliders so that the enemies stop when they hit platforms. So they don't just fall through them because that's not the behavior we want. So to do that, we can go to this create collisions. So I think in between the steps, I didn't do this, but like there was this create collisions. I just moved all the like collision code, the code that creates collisions, this that create collisions. So it's like, it's more clean, and like things are more separated out. So let's add this.physics.add.collider. I want to add a collider between this dot enemies and this dot tile map dot foreground. So they will stop like that. So let's reload. So yeah, now the enemies at least stop there. Also, I think there's supposed to be 3 enemies, but I don't think I saved this file. So you always remember to save your tile maps, or like it won't actually update in the game. You didn't save the file. So if I save it, there should now be 3 enemies. Just kidding. Why is it there's only 2 enemies? Did I misspell something? This is spawn underscore enemy, right? I do not know where the 3rd enemy. Okay, I will save this and then force reload. There were only 2 enemies showing up. You know what? It might be. Okay, the third. I mean, the bugs fix themselves usually. So the third enemy will probably show up at some point. Spawn's the enemy. Enemy.x. Let me just improve this comment. Enemy.y. So the next thing we want to do is we want the enemies to basically move back and forth. So like they're actually a threat, because if like an enemy's standing still, it's like super easy to dodge them, right? So let's do that. But before we do that, let's go back to tiled. And a problem that is like that once you add this, you'll realize is like when the enemy moves left, what happens is they walk off platforms, right? And like sometimes we want the enemies to be in like contained spots, so we don't want that to really happen. So we can make another layer on our tile map called enemy underscore collider, and then place these like, I just use this question mark tile because so it's easy for me to see here, but these won't actually show up in the game, is we essentially add these tiles here, and we check if the enemies intersect with these enemy collider tiles, or the tiles in the enemy collider layer. They should just turn around, right? They should go the other direction. So the way we do that is if we go back to create tile map and we do const enemy collider. So we want to bring in that tile layer equals map dot add, map dot create layer enemy collider, and like that. And then we just return this from there. And then we basically, in our collision code, we add a this.physics.add dot collider between this dot enemies and this dot tile map dot enemy collider. And that will essentially do that. But like another thing is we actually want when the two objects collide, we want actually special behavior to happen. We want like JavaScript code to execute. Because what we essentially want to do is to flip a flag in the game that tells, okay, this enemy should start moving left. And the way we do that is by making a function like this. So this is, I'm defining a function. And then I pass an enemy and then like tile, right? And I essentially want to do like enemy dot left equals whatever enemy dot left was not. So like this just flips it. So like if enemy dot left is true, the enemy will be moving left. And then if it's false, it'll be moving right. And then what this not does here is like, it's like, okay, make enemy dot left what it was, just like flip it, yeah, essentially. So like if we go back to enemy and then we have like a, we make like this dot left equals true. So let's say it's going left by default. And let's copy the space speed from player, but like make them slightly slower than the player. So let's say like 150. And then update, we do like, so if this dot left, so if it's going left, then we want to this set velocity x to be negative base speed. Otherwise, if it's going right, then set it to be positive base speed. And we also want it to play different animations. So let's say like, I'm actually just gonna copy this from player and just change everywhere it says player to enemy to save time. Copying code is not good usually, because like usually you can make bugs that way, but we want to save time here. So let's just put here and change everywhere it says player to enemy, enemy, enemy. And like another way, like let's say, because I have to change player all these places, right? If I hit option on Mac, I think it's alt on Windows. So if I hit option and then start clicking, I can make multiple cursors. I had to put that cursor in the wrong spot. So like I can make multiple cursors by just clicking. And I can change all these players to be enemy. And then like when it's going left, we want to play the left animation. And when it's going right, we want to play the enemy right. Okay, not play reverse, play normal. And uh-oh, let's reload. So they are moving to the left, but they're for some reason not collide. What it looks like it's happening is they're not colliding with this enemy collider layer we make. So there's probably a bug. Oh yeah, we didn't save main scene. That's probably why. Let's save it. Okay, they're still not colliding with it. So a good way to debug this is earlier we said create layer enemy collider, but we didn't pass in a tile set. So if we pass in a tile set, it'll basically draw the tiles for us. Let's see if the tiles are actually showing up. Okay, my computer's frozen. Okay, never mind. So it is drawing these. And I think what's happening is I don't see any yellow borders around these. So what I think is happening is that I actually did not enable collisions. Yeah, I didn't enable collisions. So let me write enemy collider dot set collision by exclusion. Enabled collisions. There we go. We save the file. So yeah, now it's working. So let me re-explain set collision by exclusion. just in case it's unclear. So what this does is it takes an array of all the IDs of tiles that don't have collisions. And since every type of tile has an ID that goes from 0 to like whatever positive number, there are no negative tile IDs. What -1 essentially says is like, okay, make every single tile on this layer collidable, because there are no tiles with ID -1, right? So that's kind of enemies. We are going to, there's another part that's like adding damage, but we're probably gonna come back to that later. Annie's gonna start presenting now on like adding extra mechanics. So like dashing. So yeah. Oh wait, actually before we move on, are there any questions? Any questions that like you didn't want to add while during the explanation? Okay, so to do that, go to GitHub desktop, or and you can also paste the command, is you can switch the current branch from collectibles to damage, which is like another mechanic you have. So let me just leave my changes. I'm going to get rid of my changes, but you can bring your changes if you want to. So yeah, we did that. So now if we go back to our game, there's essentially more code that we can come back to it later if we have time, but like it looks basically the same, but like now that if we run into them, you actually take damage. Well, there's no health, but like it knocks you back and it turns you red. That's another thing that happens, is like the enemies are actually harmful now. Yeah, so that's what we essentially do. So go to, again, branch 08 dash damage. So, and you can.
So yeah, so in this last section, we're going to talk about how to implement like some more advanced like platformer mechanics, like dashing, like cooldowns for dashing, things like that. And then also like if we have time at the end, maybe some like more advanced things like jump forgiveness and stuff like that. So I'll share my screen and get into it. And just so we get hyped, I'm going to show us a quick preview of what it's supposed to look like at the end, because I think it's really cool. So our end goal is to have our robot be able to dash around the map and just, yeah, you know, move freely and be a more fun game. So you don't have to walk everywhere. So yeah, this is what we eventually want to get to. And as you can also see, we kind of want some sort of effect when we're dashing, so we can like have a nice like visual input, and it just feels more satisfying when you're playing. So we're going to try to get all of that in the few minutes we have. So let's start with like the basic logic of dashing. So I'm going back to 08 damage, the branch we're starting from, and I'm going to open up VS Code. So one of the really nice things about the way that Kosi set up this project is that since we put everything into classes, I know that the only place I'll like really have to look at any code at all is going to be the player file, because all I want to do is make the player dash. So I won't really have to worry about anything in enemy.js, background.js, or even the main scene. So all of my work is going to be in this one file, and it'll just make my life a lot easier. So the first thing we need to do is we probably want to pick a key that we can press to like activate dashing. And we also want to pick a speed that we'll set to when we're dashing. So I'm going to start off by saying our dash speed, let's just say it's 1800 for now. So like a nice big multiple of our base speed, so we can go fast. And in our update function, I'm going to check if we are pressing the shift key. So let's do cursors dot shift is down. And if we're pressing the shift key, let's just do something pretty naive, pretty basic, just to test. Set velocity X to our dash speed. So this will be pretty janky at first, but it'll like get us the basic idea of a dash down. So if we go here, our game should have hot reloaded. So now if I hold down the shift key, I'll just fly to the right, right? So obviously there's like a lot of problems with this. The first one being that we can only go in one direction. So as you can see, even if I try to walk to the left, my guy is just stuck, like ramming into the wall. So we want to be able to dash in both directions. So that's something we have to like manually code in. And then we also want to make sure that we stop dashing at some point, right? We want like some sort of cooldown so you don't literally just like fly into the end of the level, right? Because that's not very like, you know, interactive gameplay. So the first thing we're gonna do is keep track of the last direction we were facing. So if the person clicked the left arrow key, we want to dash to the left when they press shift. And if they recently clicked the right arrow key, we want to dash to the right. So an easy way to track that is to just make a new state variable. There's two examples here that we made for damage, but it's not too complicated. So I can just explain it for dashing as well. So I want to keep track of the last X direction we went in. So I'm just going to make a variable called last X direction. I'll initialize it to 0 in this constructor over here. And I have to make sure to put this so it gets attached to like this whole class like object thing. Okay, so then the place where I want to keep track of these changes is going to be in this update function. So if I recently moved left, I want to set my last X direction to -1. So I know I was like going the negative direction before. And if I was recently moving to the right, I want to set my last X direction to +1. So I know I was moving to the right. And now I can just set my dash speed to my velocity, sorry, to the dash speed times the last X direction. So if I was recently going left, the speed will be negative and I'll move to the left. And if I was recently going right, it'll be positive and I'll move to the right. So now we have a slightly better dash that can go in two directions. So as you can see, I can go right, left. But then there's another problem. I can change directions mid dash, right? That's a little overpowered, you know, just like slightly broken. So we might want to tune that down a little too at some point. And I can still dash forever. So these are like the next two problems we're going to fix. And the way we're going to do that is just by adding another state variable. So this is also not too bad. The way I like to think about it is I want to keep track of a state variable that tells me what my progress is in the current dash. So I'm going to make a variable called this.dash steps and set it to 0. So this is going to tell me that I'm not currently dashing because I'm at step 0. And if this is any positive number, it means that I am in the process of dashing and I have like that many frames left. So if dash steps was, let's say 20, that means I have 20 more frames of dashing left to go. So yeah, that's how I'm going to like implement the limited dashing so I don't keep going forever. Okay. So here, things we want to do. So here, when we press the shift key, instead of just setting our velocity instantly, what we want to do is instead say, hey, let's start our dash by setting the number of steps to 20. So let's start a 20 frame dash, basically. And then we can move our actual velocity code into a separate if statement where I'm saying if I'm dashing, so if the number, if my dash step count is like more than 0, then I will set my speed to this last X direction. And another important thing here is that we want to make sure that you can't dash while you're already dashing, right? So like, let's say you're in the middle of dashing, right? Your dash steps is 10, right? You don't, if you press shift again, it'll just get reset to 20. So we want to make sure this reset to 20 frames only happens if you're not already dashing. So the way you do that is by just adding an extra fact, which is like, also make sure that dash steps is 0, right? So doing this, we should have a dash that doesn't make us go in the same direction forever. So, okay, maybe not. Let me reload this. Okay, this is broken. Okay. Oh, okay. So the problem here is that I'm setting dash steps to 20, but I'm never incrementing it down. So I have to add this step right here, dash steps minus minus, which decrements this dash steps counter. So it goes down after every frame. So I only dash for 20 frames and I'm not just dashing forever like you just saw. So, okay, wait, I have to actually reload my page. And let me just double check. Oh, I did not save. That's why. Okay. Yeah. Always make sure to Control S / Command S VS Code, or nothing will save. So yeah, now you can see I dash, but like I don't dash forever, right? I go pretty far, but I don't go forever, which is good. Another thing that we still have to fix is that right now we can like change directions mid dash. So we can just add a quick if statement to check for that. And one more thing I'm going to do is I'm going to make a function called is dashing just so like this code can be more readable. Because right now I'm like comparing against this value to like check whether or not I'm dashing, and it can be kind of confusing. So I'll just make a function called this dot is dashing by, or just is dashing right here. And you can tell if you're dashing by checking if your dash steps are more than 0, right? So here I can just replace this with if I'm holding shift and I'm not dashing, then I want to start a dash. And then if I am dashing, I want to run this code. So I will place this. So this just makes it a little more readable. And then I also want to add a check I won't only want to be able to change my direction if I'm not dashing. So then I'll just wrap this in a whole if statement. If I'm not dashing, this little exclamation mark here just means not in JavaScript. So if I'm not dashing, run this. And basically all I'm doing in this update is just like coding a bunch of like logic and like being consistent so I can come up with a good dashing mechanic. If you've heard of a state machine before, we're essentially coding this. You don't really have to completely understand what that is, but it's just one other way to think about it that's slightly easier if you're a little confused by this. But yeah, basically we just have to add a lot of like edge cases and checks to make sure that this dashing mechanic doesn't break other things. So now, as you can see, I can only dash in one direction. Like I can't turn around. I can turn around at the end, which is good. That's intended, but I can't turn around in the middle of the dash, right? Which is what we want. The other thing that feels weird right now is that we dash, but then we just like lose all our speed. It's not a gradual loss of speed. So it kind of just feels bad, or like it feels awkward to do. And we also go really far. So the way I'm going to fix this is by just like adding a damping factor for the speed. So I'm just going to make the speed start at the dash speed and then linearly decrease to the base speed. So just like a straight line down. So there's a pretty easy way to do this with the way we implemented dash steps. We can just multiply by, let's see, let me make a new variable for dash frames, just so I don't repeat the same number over and over again. So let me find this other 20, not the frame rate. Yeah, so I'm gonna set dash steps to the number of dash frames. And then if I do this dot dash steps divided by dash frames, it'll tell me what my progress is in my dash. So at the start, this number will be 1, and then towards the end of the dash, it'll decay down to 0. So at the start, we're going to be going at the dash speed, and then towards the end, we'll be like going to 0. But that's actually not what we want. At the end of our dash, we want to be going at our base speed, basically like at our walking speed. So I'm going to add in the base speed again. So this way, like if you're running this math, it'll then feel like a lot more normal. And another important thing is to remember that this X direction multiplier should be applied to everything. So I should just take this out and add some parentheses because order of operations matters. So yeah, I'll just modify the direction for everything. So I want to start going at the dash speed and then slowly decay down to the base speed is basically what this code is doing. And then when we try this out, you can see, yeah, like we like slowly decay and get back to our normal speed, which feels a lot more like normal and what you'd actually expect from a game. Okay, and then there is the last part, which is how do you add the effect? Because right now you're just moving, but it doesn't feel that satisfying, right? Also, there's this bug with damage where like you keep running into someone over and over again, and it's just really jank. So we probably also want to add a quick fix for this. So if we look through this damaging code, we want to not take damage if we are currently in a dash. So we can just search through really quick. Handle damage. Yeah, so we want to add something so that we don't damage the player if they're mid dash. So we're going to do see if it's damaging and we are dashing, we're going to just return at the top of this handler so we won't take any damage. And then hopefully, oh, that did not work.
So you actually want to put those into two different if statements, because what the handle damage, we didn't like talk about this, so it's fine. The handle damage is it's checking if it's like currently damaging you, and it returns, because what happens if you don't have that check is like it will keep running that function over and over again, even though you're already taking damage. So you need it, yeah, like so like that. You can just like have a separate check.
Yes, that was just a little buggo. And now, yeah, we can dash through people and it's not super jank. It's very satisfying and clean. You can dodge them out. And also right now you can dash through walls, but that's a bug left up to the readers. You know, we can work on that later. But we will try to add the effect right now. So in dash steps, let's see, wherever we're decrementing it, I'm gonna scroll. Okay, yeah. So right here, the effect we basically want to do is we want to redraw the player with a certain alpha, and then just leave it at the current position. So it looks like you're like leaving a trail of after images, right?
By the way, when he says alpha, I think he means transparency.
Yeah. So alpha is just like yeah, basically a transparency channel. So your image looks like more faded and blended into the background. So it's not as prominent as like the character itself. Okay, so let's see how you add images. Let me check really quickly because I kind of forgot how images are added. So, okay, I have to do something. I have to add a sprite. Okay, so basically I want to add a sprite that's a copy of the player at the current position. So I'm going to make a variable called after image. And this is a much more complicated than the actual dashing mechanics. So it's okay if you don't completely understand this, in my opinion. So don't worry too much about it. So I want to add, yeah, this .scene.add sprite, and I want to add it at the player's x coordinate, this .x, this .y, and I want the texture to be the player texture. And I can just pass in the string player, and Phaser should be able to just pick up the correct sprite that I want to use. And we can try testing that right now. We didn't add an alpha channel or anything, so it will look a little jank. But yeah, so yeah, right now you can see we do generate copies of the player image, but they're like definitely at the wrong size. So we have to scale it down. And the way you do that is by copying the display width and the display height for the image. So let's do that. After image display height equals this dot display height, and the same thing for the width. So this will fix our image being too massive problem. And then we also want to set alpha. And this, like we said, just like sets how transparent it is. And it's a float between 0 and 1. For now, we can just set it to 0.5. You'd probably also do some cool decay thing like we did here for the speed. That would probably look nice too. But for now, we'll just set it to 0.5. Okay, so now if we dash, we leave a trail of after images. But the problem here is that they stay there forever, right? Like I'm just drawing on the screen, I'm painting. and eventually our screen's gonna get really cluttered. So what we want to do is we want to create some sort of like method to organize these after images so we can delete them after a specific amount of time. And usually the way you want to do this is just by adding this thing into a list and then keeping track of how many ticks it's been alive and then delete it after a specific amount of time. So I'm going to make a new state variable again, a lot of state. So I'm going to make a state variable called dash images. And this is just going to keep track of all the after images we put in. So right here, I'm going to add the current after image to this dot dash images. And the way you add to an array in JavaScript is push. So this creates a new element. So I'm going to push after image. And then I also want to keep track of the amount of ticks that this image has like been displaying on the screen. So I'm just going to set the current number of ticks to 0. And then in this update function, I'm going to loop over all of these dash images. In JavaScript, when you're looping over objects, make sure you use the of keyword. If you loop over the in, if you do for image in dash images, you'll loop over the indices instead of the actual like values in the list. So make sure you always use of if you're used to Python. This is like a very common bug. Lots of people get tricked by this. So I'm just gonna, for each image in this list, I'm just gonna increment the number of ticks. And then if the number of ticks is, let's say 20, let's say I wanted to delete it. I'm gonna first set it to deleted so I can keep track of the fact that it was deleted, and then I'm gonna find out how to remove the image. I think, sorry. So yeah, okay, I'm gonna try to speed this up a little. So yeah, like most like objects in most object-oriented languages, you're gonna have a destroy function. So in this case, that's the way you delete the image. So here I'm just gonna do image.destroy, and this should delete the after image after 20 ticks. The other issue we have is that we never remove these things from our array. So one quick and easy way to do that is to just filter our dash images array. And the reason it's nice to do it like this is that JavaScript has a very like nice built-in filter function, so you can just code it really easily. So for each image, I want to only keep it if it's not deleted. So I want to return image not deleted. So this will delete every image from my list, or this will only keep images in my list that are not deleted. And I mark each image as deleted as I destroy them. So then this code should run and delete our after images as we make them. Okay, so let's see. Yeah, so as you can see, we dash and then our after images disappear. There's a little delay, so maybe I will just delete them after like 10 ticks and see how that looks. But yeah, you can like play around with all these numbers and your images. Your things will look different. Your dash will be either cooler or less cool. Right now, we kind of draw a lot of images. So in the actual like production version, one thing I did was only run this after image step like every other frame. So only if this dot dash steps is even, which you can just check by running mod 2. So this way it doesn't like junk up your screen as much by drawing too many, by like drawing an after image every frame. So this will also look a little better by virtue of just not drawing as much. And then we'll have like a slightly cleaner dash effect. And yeah, that was pretty much it for the dash section. I guess I will stop sharing now and see if anyone has questions. Yes, my bot does have the zoomies. And if you got lost at any point in that, or you just like want to see how I implemented the dash thing personally, I think there's a few differences in like the latest branch. You can just git check out, let me see, branch number 9, which I think is 09 dashing. So I'll send that in the chat. And then you can see how the dashing works. But yeah, that's like one cool mechanic you can do with platformer games, and it's very fun to play with and code.
So I think this is actually the conclusion of workshop number 3. The next workshop will actually be given by someone else, a volunteer from MIT's own game development club. I think they're called the Game Development and Design Club. His name is David. So yeah, you'll be talking more about like the other aspects that are really important about games, like design and history and level design and making art, and less about the programming part, which we kind of focused on in the first 3 workshops, because game development is actually a lot more than just programming, and it really requires like a lot of creative aspects too. So hopefully it'll be fun. But yeah, I think that is the conclusion for this workshop. We will stay on for like a couple extra minutes and answer questions if there are any. We will send information about when the next workshop starts in Discord. Everything kind of got a little bit delayed. So originally supposed to start at 5, but I think we'll start later than that, just so we have a break. So yeah. All right, the workshop is officially over. You're free to go if you want. Stay behind.